Good afternoon all. I've got a box from JLCPCB. Guess what's inside? Well, it should be fairly easy because it says prototype PCBs for only $2. So let's take a look at what's inside here. Well, we have a couple of pens branded JLCPCB. We've also got some LEDs here, a little pack of 3mm LEDs. It says first order. So I guess that's a free gift for your first order. And this jiffy bag. Let's see what's inside here. So these are fairly obviously printed circuit boards from JLCPCB. And I'm very pleased to say that JLCPCB are actually sponsoring this video. So thank you very much to them. Right, let's take a look at these. These are sealed in some sort of double-sided bubble wrap stuff. So I should be able to break them out of there. So yes, what have I committed to a printed circuit board? Can you guess from my recent projects? Yep, it's Julian's Knight Rider. So I've no doubt you'll remember this little thing which I made up the other day, my little Knight Rider LED scanner where the light bounces backwards and forwards. Well, I decided that I'd quite like to make a printed circuit board version of this circuit, so that's what I've done. I spent, I don't know, an hour or so designing the schematic and the PCB layout, and I've come out with this. Yes, I remember that well. So these are quite interesting because they're actually double-sided boards. You can see that the all the pads are plated through holes, but there are actually no topside tracks at all, and that's because I suppose my sort of instincts from years ago kicked in, and because I could get all the tracks on the bottom side, I decided to put them all on the bottom side. But yes, these are actually double-sided boards with no topside tracks. Right, so it's pretty straightforward. We've got a 555 timer here, pretty much as I've got on there. 4017 there. The, what is it, 10 resistors, I think it is, all along there, and the 6 LEDs across the bottom here. Now, interestingly, the software defaults to putting component numbers on the board, but actually for this, it would probably be more useful if I'd put on actually the value. So if I just put these are all 100 ohms, these are red LED, 4017555, the pot, I think I used 100K, and capacitor, that's 1 microfarad. That's a tiny little capacitor I've picked there, isn't it? Actually, that might work quite well for the tantalum. And this little 2-pin connector, which is going to be a sort of DuPont style connector. Yeah, do you know, I think I'm actually going to make one of these up right now. Right, so let's warm up the soldering iron. I'm going to use my Antex for this. Okay, I found a 555 bipolar, boatload of 4017s. Now I need some 100 ohm resistors and some LEDs and a pot. Right, 100 ohm resistors. I think I'll need to cut off another bunch of these because I don't have enough in my component drawer. 100 ohm resistors there, and I've got plenty of LEDs in here, and I'm going to use the red ones, of course, because this is Knight Rider. So let's get started. Right, I might need my helping hands. I'm almost certainly going to need some blue tack. Well, let's put the 555 in first. Now, while I assemble this, I'm going to intercut some shots, some screen grabs that I did while I was doing the schematic for this and the PCB layout, so that you can see how this printed circuit board kind of evolved. So let me just check some of those out now. And the first thing I'm going to need is a 555. Now I've got a feeling there's one right here in this panel. Yeah, there it is. It's NE555P, so click that and drop it onto my schematic. Right click to get rid of the floating one. Right, a bit of blue tack to hold the 555 in, and that will also stop it sort of sliding around on my desk a little bit while I solder those pins. Yeah, I just love my old Antex. Now, if you're asking the question, why aren't you using sockets? Well, because I've got lots of these PCBs, haven't I? I've got 10 of them. I don't need 10. Actually, I might give some of these PCBs away. Would you like a Knight Rider PCB? Right, let's put the pot in. So this is the blue and white pot. I'll put in a little insert video clip where I was looking for the right kind of pot to put on my schematic so that it would be the right footprint for that of the potentiometer. But I was looking through these pots and they actually have blue and white adjustable resistance RM065 and the pad looks about right. Now the capacitor, I've actually gone for a tiny electrolytic, I think. The only thing I haven't routed is that line there, but of course if I choose a different capacitor with a larger gap through the middle of it, then I can run this VCC through that cap and then I can do that final wire route there. Yes, it's not quite the right footprint for a tantalum, but I think I can make a tantalum fit. But you see, I mean, this is all part of the learning process. Yeah, you see, I'm going to have to push that in now. That is a very tiny couple of pads there, so I have to push that in. I won't push it in too far. Right, let's get those two soldered in, because what I can do now is put an LED with integral resistor onto 2 pins of this thing here, power it up and actually watch that flashing. Oh, those pads are extremely tiny. Probably should have gone for a larger capacitor and maybe even searched around for a tantalum so that I got the right footprint, but never mind, that's pretty close. I'm not holding the board to my mat, which is really silly. It's so easy to solder plated through holes. It's difficult to unsolder them, but they're beautifully easy to solder. Now I seem to remember that pin 3 on the 555 goes into pin 14 on the 4017. That's kind of why I laid them out like that, because there's, well, you can see it on this side, just a wire link running straight across there. So if I put my LED with integral resistor between pin 14 and pin 16, which is VCC, of course I've got my flat, my cathode, to the 555, and I put power on there, well, that should flash on and off, shouldn't it? Right, let's give it a try. Pretty sure that top one is positrons and this one is negatrons. Oh yeah, that works. That's fantastic. Let's turn that pot. I can't turn that pot with my finger. That's fast. And that's slow. Yes, I mean, my 555 circuit's correct. Let's press on with the 4017. And now I need the 4017. So I'm going to have to go into the libraries. Okay, yes, here we are. In LCSC, we do have an HCF 4017BE, a DIP 16. That will do nicely. Let's click that and say place, is it? Yep. Lots of 4017s I found, all the same make. Motorola is that, I think. They've got splayed pins, so I'm going to have to bend those in. So I'll just press it down on my mat. I know this is CMOS, but I think the modern CMOS chips have protection diodes, don't they? I don't think the original ones did, but I think I read that somewhere. Right, I'll pop that in there, and blue tack, and let's break that into 2 pieces. Put one either side. Actually, I should put it at the ends, really, because if you put the blue tack actually on the pins that you're heating up, it tends to go all gooey. I mean, it does go thick again once it's cooled down, but yeah, that'll do. Let's solder that one in. Right, let's solder all 16 pins, I think it is, of the 4017, and these being tin plated. Now actually there's an option for leaded or lead free, and because this is not a commercial PCB, I went for lead because I just felt that if I'm using leaded solder, which I am, on pads that are tinned with a lead-based solder, I'd have less hassle soldering them on. Yeah, that's gone in quite nicely. Right, let's take some resistors Someone was talking about pulling these out of glued bandoliers. Yes, sometimes the glue goes all gooey, but most of the time it's not gooey and you actually don't get, or you get very little glue contamination on the ends of the leads, so I'm not too concerned about that. I think we need 10 of these. So let's take that. I need to type R to rotate it. And I need how many resistors? 1, 2, and then 2 4s are 8. So I need 10. So let's place them there, 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 and so on. And I'll put 10 of these resistors across here in a long line. In fact, I'm just going to put one LED in and the 2 resistors that go to it, and then do another test. Right, I've used a pitch on these resistors that's a little bit small for these quarter watt ones, or are they 0.6 watt? I can't quite. No, I think these are quarter watt carbon film resistors, so that's not ideal. Well, I mean, you know, this is partly a learning process for me to make sure I pick the right components out of the library. So what do? I think what I'm going to do actually is just bend these very tight to the ends, and then they should drop in there quite nicely. Right, the next thing is get all these resistors up. Now I'm going to put my finger over the R key so I can rotate these as I go. Let's lift them up, rotate them, and drop them down here. We can go quite close to the LEDs, I guess. R2, rotate. Right, let's put these 2/10 apart. And that might make them all fit in. I can't do the maths in my head, but it might work. Rotate them and drop them all into position. If you just hover over them, they kind of select. That's really cool. Right, so I've got a couple of 100 ohm resistors in there, and if I flip that over, you can see that they are both connected to this LED. So I'll put that LED in, put some power to this, and just see if we get a double flash on that LED, which will mean that it's sort of working in its part of the sequence. Yeah, I mean, some of this, it's just fairly intuitive to me that moving the resistor would make more sense. For example, moving this one, R10, that seems to be selected, over to here would make logical sense because that rubber band line goes to pin 1 of the 4017 and that goes to the left-hand LED. And my 5mm LED fits in there absolutely perfectly. In fact, in some ways, it's almost too good because it's now loose and rocking around. And it's quite nice sometimes to have the component fit in the hole a little bit tight so that you can just wedge it in there and you don't need to use blue tack or other techniques like bending the legs, which I really don't like actually. So please don't suggest I do that to hold it in. So let's solder those 3 components. So that just makes sense to me to move that one over there. And there are going to be others. This one, R1, looks like it could move pretty much the other side. Let's actually try it. Let's hover over that and move that there. But how far can I go with this before it all starts turning into a bit of a nightmare? I don't know. Right, resistors. That's those done. Working around the stalks. My LED. That's that. Okay, so I'll just cut those leads off and put some power to it. The numbering will be arbitrary, but it's irrelevant really because these are all 100 ohm resistors, so it's almost worth removing this numbering. I don't know. Right, let's once again borrow the 5 volts from my little Knight Rider up there. Let's put that there. Plus to there, minus to there. And there's my double flash. So that looks very promising. Right, so let's just continue to solder all the other parts in. Yeah, so this has all got into a bit of a tangle because it looks to me like R1, let's hover over R1 and bring it out. And R7, let's bring that one out, are linked here as they go to LED 3. So it does look like those should be paired. These two should be paired, R8, which can go there, and R9, which can sit next to it. So yeah, I'm having to bend these resistors quite tight to the body so that I can put them into the rather undersized resistor positions that I designed on this board. Well, you live and learn, don't you? So let's get those bent nice and tight to the body. Now I should really put, for the outer two LEDs, should really have 220 ohm resistors, or 200 ohms or something like that. But I think my OCD would be more affected by having a different color resistor on the board than by having the end LEDs a bit brighter than the middle LEDs. So I'm going to use 100 ohms across the board. Right, let's track the no-brainers first. So that one we can see can come down here, run under these. Let's make it nice and neat. I'll smarten this up later, but that can go onto there. Right, that's all the resistors in. Let's flip it over and solder it. There are three here actually that all follow each other, so let's do these. That one, let's have it come down a bit, come across a bit. Yeah, I'm making a bit of a mess of this, but that one, and then there's the one next to it which follows exactly the same path. Let's do that. Yeah, I know it's horrible, isn't it? But bear with me. I have to say, I'm thoroughly enjoying this. It's so nice to turn what's a rat's nest on a piece of breadboard there into a beautiful work of art on its own dedicated PCB. And then this third one here follows again exactly the same path. Let's go to there, come down here. Oh no, that's ugly. Yeah, this is much fun. That one's sticking out. Oh, I bent that one out to the side. Something I said I'd never do. Well, I do it sometimes when it suits me. Yeah, it's amazing what you can find when you look for it. So I can take that topside track out. Let's delete that and actually track it on the bottom side, because it will go... Oh, I'm on the track tool. It will actually go around here, up there. Let's try and make that as neat as I can. And to there. There's almost nothing left. Weaving my way in and out of the component legs here. That one's a little bit loose. Right, last two, which are over here. Tracks are quite thin, but I went for 10 mils. So I think the track width is 10 thou. It's 100 thou between pins on a chip. Yeah, you see, my sort of single-sided routing instinct has taken hold, and I've pretty much routed the whole thing. I can route this one up through there and round there. So pretty much the whole thing could be done single-sided. And in fact, if I take U2 and rotate it that way and bring it sort of sitting in the middle here, and then take U1 and put it out over on the right, because pin 3 there goes to pin 14, as we know. Where's my little bucket of offcuts? There it is. So let's cut these off. Yeah, you see, rather irritatingly, this whole thing has now routed single-sided. And that's all the resistors done. So now I just need to put the LEDs in. There is a place here for a resistor. It's called R11. Now this is a bit of a cheat, because when I tried to lay this entire thing out single-sided, one track I couldn't route. And this track actually is just pin 4 of the 555 going up to VCC to hold the reset line high. Now you don't need to fit that, and I'm not going to bother actually, because these bipolar 555s, that reset line, I've never had any problem with it. Certainly not going to be a problem from the point of view of just watching the little light display. So yeah, I'm not going to bother fitting it. And this is VCC here, which can route down to my power connector, which will sit on this edge of the board. So yeah, the whole thing has routed single-sided, so no need for a second side. Right, fit my LEDs. Now they're all wobbling about because they're quite a loose fit in the board. So I'm going to have to use blue tack to hold them in. Maybe I can use one piece of blue tack per pair of LEDs. You want to get these in nice and square because, well, this is the bit you look at. This is the sort of pretty end of the project, isn't it? So I'll put blue tack either side of these LEDs, and now I'll just push them all flush to the board, and hopefully I won't get any LEDs at wonky angles once I've soldered it. Right, well, this is the last components going in, so let's solder LEDs. I don't want to... Oh, my helping hands is wobbling around. That's a real nuisance, isn't it? The cathode. Good, those are all in. Let's clip them off and put them in my little clippings pot. And the Knight Rider should be complete. And there she is! Finished printed circuit board. Well, I've every confidence that this is going to work, so let's grab that battery pack again. Right, should we power it up? I've got my positive up there, my negative there. Oh, it's a bit jumpy. Oh, it's probably because I've got rubbish connections here. Yeah, this was designed to take a 2-pin sort of DuPont style header, but that is fantastic, isn't it? That's working beautifully. I'm really pleased with that. So much better than the breadboard version. Right, since the intention was to put a 2-pin DuPont header on the board, let's actually solder that onto there, and then I can get some DuPont wires and link them across to here, and we can have them both running together. Ah, look what I found. I found a red and brown DuPont with male one end and female the other. What could be better than that? Not much, really. So let's plug that on there, and now we'll pick off plus and minus from this board there. Is that the right way around? I think it is. Oh, it's quite a tight fit in there. But yeah, there it is. Yeah, I'm really pleased with that PCB. That's a lot neater than that. Yeah, so for next time, one thing I would definitely do is, rather than put the legends of sort of U2, U1, R, 1 to 11, I think I'd probably take those off, and on the silk screen I'd put 100 ohms times 10, 100k pot, 1 microfarad there, 555 as the legend there, and 4017 there. Julian's Knight Rider without a K. Not entirely sure why I did that. I think it was in the back of my mind, I was thinking, oh, maybe there's some copyright issues. I don't suppose there are any copyright issues. Right, let's have a little twiddle of the pot. Now you'll notice I didn't put end stop resistors to prevent this locking up. So, oh, it doesn't lock up that way. It goes really fast. This way, yeah, it locks up. So, I mean, yeah, you could put a resistor in with the end of that track to prevent this locking up, but actually it's quite handy, isn't it, if you want to have a random, yeah, it's a game look. Try and stop the LED on a particular position. But yeah, that's nice. Now, of course, this PCB, I wanted to do something nice and easy, so I picked this simple Knight Rider circuit because, I mean, I haven't actually done any PCB design, layout and manufacture. I used to make all my own PCBs, of course, had all the ferric chloride and fish tanks and all that stuff. Haven't done that for years, so I just want to sort of ease myself back in gently. What I really want to do is get the PWM5 solar charge controller on a PCB using all surface mount components, but this was just to sort of dip my toe into the water. So there it is. A huge thanks again to JLCPCB.com for both sponsoring this video and supplying these PCBs. But yeah, there's my PCB Knight Rider project. Cheerio.